All right, so here's the problem we're going to work on real quickly. We don't have a few minutes. If you have 450 point, and I got a point, why did I put that decimal place right there? You think that's what I meant? Could there be another explanation for why I put that decimal place right there? What would be what would that show? The zero, that decimal place right there is a way of showing that this zero is significant. If it weren't there, you'd have to assume the zero is not significant. Does that make sense? Okay. So 450 cubic centimeters at 37 degrees, and it's cooled to 18 degrees, and find the new volume. So we're listing all of our knowns and unknowns, and somebody correctly noticed that I've got two different temperatures. So one has to be a beginning temperature, and one has to be an ending temperature. And if you read it, there's a verb that says it's cooled, so that's the ending temperature. Okay? So that would be 2, and this is the starting temperature, 1. And this volume here goes with that 37 degrees, so that's volume 1. And then it asks to find the new volume. Well, that must be volume 2 that goes along with this temperature. Please stop playing with your balloon. Thank you. And why did I put those red flags up there? Because you got to change those to Kelvin. Okay. So to change temperature 1 to Kelvin, you've got to say 37 degrees C, and you add 273.15 to that. And then you get 1.5 on the end, and you get a 10, that's 11, and a 3, right? And that's the Kelvin temperature, which we round off to 310 K. But I need a decimal place right there. Why? That zero is significant. You've got to show it. You can write it in scientific notation, but it's kind of a shortcut here to put a decimal place right there. Okay? All right, we need to change the other temperature as well. $391K. No, 291K. What is the matter with me? 291K. Sorry about that. Alright, so now we got our temperatures changed. So this one's 310K. 291K. Don't need a decimal place. I'm not sure if that's a stray mark or what it is. But anyway. So now we need to figure out what equation fits this. I've got variables of V1, T1, V2, and T2. What law is that? Charles' law. Charles' law is written V1 over T1 equals V2 over T2. Okay? So now we have listed our knowns and unknowns. Along with that means changing any temperatures to Kelvin, because that's what you have to do. Your units of measurement have to match, and any Celsius temperature has to be changed to Kelvin temperature. Now we're ready to, then I wrote out the equation. Now I'm ready to plug in the known values. I've got 450 cubic centimeters, that's volume 1. Over 310, okay. Volume 2 we don't know, so we leave it alone. And then we've got 291K for our volume 2. The next step then, after you plug in, is to isolate. You want to isolate the unknown. And the unknown in this problem is V2. Okay? I want to get that all by itself. So mathematically, if I want to get it by itself, I've got to do the same thing to both sides. And whatever that thing is I'm going to do to both sides has to get the V2 by itself. And what we do to get to that is we multiply by 291K over 1. Remember, I have to do it to both sides. Okay? And that allows me to cancel all of this, because 291K over 291K is the same thing. I mean, it means it's 1. They cancel each other out. Okay? So over here on this side, what can I cancel anything over there simplified anywhere? K's can go away. Okay? All right. Now we're ready to do the math. This times this, it equals, divide by that. Here, that's a 2. If you did it in your own calculator, you'd know. Oh, that must have stung. Just joking. I'm just playing. It's your day to get picked on today, I guess, huh? Okay. What? Oh well, I got to stop doing that. I got to pick on other people. Yeah, I've been picking on Julie lately. Maybe I haven't been spreading around enough. All right. How many significant digits do I need? 3. Anybody listening to this video, by the way, we are. It's all in fun, I hope. All right? Is it? Okay, everybody. No, it's not. If it's not in fun, I gotta stop. Does she really? No, she doesn't. Really? No. Okay. Thank you. I hope not. She told me she doesn't. It's cubic centimeters. You can't trust what she says. Are you saying that? Really? Huh? Done. All right. So I did that one for you, but that needs to be on your homework nevertheless. Okay. Now, I will not be here tomorrow. I will not be here tomorrow, but I got stuff for you to do. Okay? You go home, you explore. The homework is to take that lab thing we did, the Cartesian diver, go home and play with it, and figure out what scientific principles apply to how it works. One of the scientific principles is has to do with the gas law. But there are at least 2 others you should know about. One we talked about in this class, and one that came up in your physical science class. Okay. Yeah, it's home. This is homework, and that's homework. What are we doing tomorrow? I have work for you tomorrow. Practice work mostly. Huh? Yeah. I'll be here for a little while after school. All right. Okay. Now, I have left information for the sub.
Who's the sub?
I don't know yet. I don't know. Hold on, listen, just 1 second. I've left information for the sub on how to reach me if there's an emergency or something. Y'all can't get through some problem or whatever, but hopefully everything's here. And if you get stuck, you know.
Pray to Jesus.
Pray. Heather can help you. Heather will solve all the problems for you. All right.
Does that mean you won't be here after school tomorrow?
That's correct.
Okay, so next day after Monday.
Yeah, that should be fine.